Okay.
Lesson 74, finding the discriminant. So before we just go right into the notes, I want to ask you, or I want you to think about the quadratic formula. When you use the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a, when the square root is positive, so the radicand is positive, you're going to end up with two answers, because a positive square root, you'll have the plus or minus, so you'll end up with two answers. What if, so imagine, what if that radicand is equal to 0? So you're plus and minus 0. So how many answers would you have? If you want to answer, just put up a finger or two, or however many. You'll have one answer. What if the radicand is negative? So you have a negative number under the square root. You're not going to have any real numbers, right? But you could have two complex numbers. Okay, that radicand, the b squared minus 4ac, is called the discriminant. So if you look at the discriminant, that's it. You know, you have your quadratic formula. Just look at the discriminant. You'll be able to tell if there's two solutions, one solution, or two complex solutions. So the discriminant is what is under the square root sign in the quadratic formula. B squared minus 4ac is the discriminant. So if you look at that, and if it's greater than 0, you're going to have two solutions. They're going to be real, and the graph will cross the x-axis twice. So there'll be two x-intercepts. So when you're asked, will the fireworks reach the top of the bridge? If the discriminant is positive, it's going to reach the top twice. Well, the fireworks will probably explode. But if it could go through, it's going to reach that level and come back down. If the discriminant is positive. If the discriminant is equal to 0, it'll reach the top, and that will be the maximum. So b squared minus 4ac, if it equals 0, it's going to be one real root, or one real solution, and it's going to have a multiplicity of 2. And there will be one x-intercept. So the parabola of the quadratic, the graph will just sit on the x-axis. Then if you have the discriminant less than 0, you're going to have 0 real roots, 2 complex roots, and 0 x-intercepts. So I'm going to show you a few examples of how we would want to use the discriminant. So use the discriminant to describe the roots of this equation. (27) x squared plus 3 equals 18x. So what I'm going to do is get it in standard form. So I have my x squared, then x, and my constant equals 0. So I have 27x squared minus 18x plus 3 equals 0. So if I just look at the discriminant, b squared minus 4ac, that's going to be negative 18 squared minus 4 times 27 times 3. And when you plug that into your calculator, you get something really big. Let's see, negative 18. 324 minus, and then 4 times 27 times 324. So you get 0. So there's going to be one real solution with multiplicity of 2. So let's say that we want to know if there's a story problem. I gotta make something up. I'm not very good at making stuff up. Okay. A miniature rocket is launched, and its height is described by this graph. Will it reach 25 feet? So we set that equal to 25. Right, why 24? This should be 25. So we subtract 25 from both sides, we get negative 13, negative 8x squared plus 30x minus 13 equals 0. Then we look at the discriminant, b squared minus 4ac. So we have 30 squared minus 4 times negative 8 times negative 13. So 30 squared is 900. We subtract 4 times 8 times 416. And this is greater than 0. So will it reach 25 feet? Yes. In fact, it will reach it 2 times. So it's going to reach 25 feet on the way up and then on the way back down. Okay. That's all the examples. If we were to do an example and it was less than 0, then you would know it wouldn't reach the height because it would have complex answers. It wouldn't reach that height at all. Okay. That's it.